Hello, my name is Jordan, and I am in the Control Applications, which is a fourth semester at CVTC. We are working on our final project, and I just thought I would go over a couple things that were involved in this project, and this would be myself, Jordan, and Robert, who worked on this. So the components we used in this project, we used a master PLC, and we used a slave PLC. We used the AC Flex 4 drive. We used a quarter foot bar motor and the master control relay, which we used to create a disconnect. And then there was a lot of wiring that went into this one. Some challenges we ran into with this project while we were in the process of making it was the click software we used. We were not familiar with, so it was a pretty steep learning curve to try to figure out all the different aspects of it. We worked with a lot of different softwares over the semesters. Studio 5000 was the one we used more exclusively than this one, so this was kind of a challenge when we jumped into it. Proper labeling. A lot of the components were labeled, but they were labeled previously before we started working with these components, so they were incorrectly labeled to what we were using them for, which came down to us taking off old labels, putting on new labels, and making sure then that went into our diagrams and logic. The AC, that drive, that Flex 4, that was the next challenge, was you have to program that while it's live and has power, so obviously you have to suit up in the proper PPE. This can be a challenge just because you're kind of awkward and clumsy in a lot of the heavy gloves, so you end up doing a lot of your programming using something like a pencil or something to try and hit the buttons on that drive. This wasn't so much of a challenge because once we went through the manuals, we figured out what buttons needed to be used and what needed to be changed. From there, it was just simply printing it off and then going over and using that while you were programming it. That was pretty much the biggest challenges with this project. I don't think there was a whole lot else that really proved to be difficult. But then, yeah, so now we can go through some of the logic and give you some brief explanations of each, the master and the slave PLC. Hello, my name is Jordan and I'm a student at CVTC. I'm in the Automation Engineering program and this is my fourth semester project. What we've got here is a PLC program using click programming. I'm going to briefly go through and explain what it does. We actually have two PLCs in this program. We have a master and a slave. This is the master program, and I'm just going to quick tell you what it does. So the first rung up here, this is a start-stop rung. We have a stop bit here, we have a start bit, and then we have, this would be our cutout. This is the drum complete. So when the drum is finished, it's going through its cycle. It is going to cut out this rung and stop the system. This is our sealant. So when the system is started, it's going to seal it in, so you don't need to hold down the start button. The second rung here, this is our drum run. So when all these conditions are met, our drum is going to start. Now the way a drum works is it's going to cycle through all of its different steps. It's going to go step 1, 2, 3, 4, etc., etc. As those steps are made, there's different outputs that are then made based upon which step it's in. So as you can see in all the steps, output 1 is made. In number 2, this is only made through steps 2, 3, 4, 5, and 6, and it is off for steps 1 and 7. Same thing for 3, same thing for 4. When this drum runs all the way through, this is when it would hit the C10, which is up here, and that would cut out and shut off the system. This has an enable rung and it has a reset rung. If either of these conditions are met, this will be reset back to step 1 and the thing can be started over. Rung 3 is our system running to let us know, hey, the system's on. Over here, this would be our solenoid that's going to hold the ball in the ball shooter, which you'll see later. All of these conditions are different conditions where this will be made and this will be out. This would be the limit switch. Yep. So then number 4, down here, this would just be solenoid 2. It's the same thing. When this condition is made, the solenoid 2 will be out. At rung 5, this is when the drum hits step 4, it is going to pause at this rung. this rung is when it's equal. You can see this is an equals here, so when the drum system equals step 4, it's going to pause the drum system, and that this is where then we will pause the drum system. After it's paused, it's going to tell it here that it's paused. This is going to go to our scans for our send and receive commands, which were the two main commands that allow us to use the master-slave PLCs. Once it's paused the drum sequence and it's holding the ball, it is then going to send a command to the slave PLC. That slave PLC will receive the command, and then there's another portion that will explain what the slave does. But once those conditions have been met in the slave, then the slave is going to send to the master here, and the master is looking for that with a receive. When the bid is made for the receive portion, then our scanning will pick that up and say, hey, the slave's done. Once the slave is done, it's going to start our drum back up. So the drum is going to start right back up where it left off, and then this 1 second timer is going to then drop the ball will hold for this 1 second. After that's held for the 1 second, it's going to drop out and then continue through its process of the drum. Down here we have fault bits, so if at any point this system doesn't do what it's supposed to, if a limit switch goes off, anything like that, that's not supposed to, it's going to fault out. It's going to let us know with a fault light, this red pilot light here. Then these would be the waiting for the fault. These are more of these conditions that have to be met for those faults to be made, because after a certain portion of time goes past, that's when it's going to fault out. This would be our final then one for the sending. This will send to our slave to tell it, hey, it's time to shut off. It's going to send it, and then it will kill power to the slave. The slave will shut off and kill the motor, which is the final aspect in this. And that is pretty much the whole program here. We will have a second portion explaining what the slave does.
Hi, this is Bob. I'm going to explain to you how the Slave PLC works in our 4th semester Control Applications final project for Automation Engineering Technology Associate's degree. And in this, when the master PLC sends the command, it is sending the C3 start bit to start the sequence, which will energize C1 start seal in, which will seal in through this bit around the start bit to keep it energized. When that happens, it will also start rung 2, the C1 start seal in, which will start the motor, which is connected to Y001 output, and the motor is on the trainer. Once that is started in rung 3, the motor runs, goes up to set point 1, which is 30 Hertz, which will energize Y002. When Y002 is energized in rung 4, it will start the 2-second timer. It will also energize input X001 wired into the PLC, which will increment the counter by 1. Once the timer is done, the T1 bit will energize. In rung 5, you already have the Y001 bit energized. It will energize the T1 done bit, which will have the motor ramp up to set point 2 at 60 Hertz. Once that is done at Y003, it will seal in so the motor will stay running. It will also energize input X001 to increment the timer, or the counter, sorry, to increment the counter. Once the done bit is made, that is CT1, that will send back to the PLC, the master PLC. The master PLC will receive that, run the rest of its program. Then it will send back to the slave PLC the C2 stop bit, which will de-energize C1 start seal in. And it will also, C2 will also reset the counter back to 0